Hello, welcome back to another episode of Coding with Culp. Today is a great day to learn how to code. And today we're going to take a look at something pretty basic on the Arduino. We're going to look at digital input. We are going to learn how to build a circuit with a button, learn how to read that button, learn a little bit about what pull-up and pull-down resistors are and what an interrupt is. So let's take a look at our learning targets real quick, and then we'll take a look at the circuit we're going to build. So our learning goals, number one, we want to know how to build a circuit with a button. We're going to know the difference between a pull-up and a pull-down resistor. And if you don't know what those are right now, don't worry. That's part of the lesson. We're going to know why a pull-up or pull-down resistor is even needed in the first place. We're going to be able to use digital read to get a button state or to read a button, or really any type of digital input. We're going to know what an interrupt is and how to attach an interrupt or an interrupt service request or callback function to a particular pin on the Arduino. So real quick, let's take a look at a drawing of the circuit that we're going to build. Then we'll head over to the workbench and we'll go build that circuit. Okay, so here's our circuit. And you can see we have the Arduino Uno right here. We have our breadboard. We have our button. So let's talk about the button side first, because we've already built this circuit before, or something similar to it. It's just a straight up LED circuit. So right here we have a push button. If you bought the Elegoo Arduino Uno kit, you'll have a couple of them in your kit. Notice that it straddles that center line on our breadboard. We're going to attach the right leg, the right lead of that button to digital pin number 2. D2 on our Arduino, and it's important that we use pin number 2. In reality, any of the pins, any of the digital pins will work. However, there's something special about pin number 2, and I'll talk about that a little bit later when we get into interrupts. So you're going to run a wire from one leg of our button to pin number 2. And then the other leg is just attached to ground. So I should have went over that first, actually. What I've done is I'm going to attach ground, our ground pin, right up here to this row. So that means that everything along here in this row has a connection to ground. So I'm going to run one wire from my ground pin right up here to that second row, the one that straddles that blue line. I'm going to do the same thing with 5 volts. So right here on the other side of the Arduino, I'm going to run a red wire around to the bottom row. That bottom row will then have a 5 volt connection. We're actually not going to use that 5 volt connection to start with, but we will use it a little bit later on. So once again, button straddles the dividing line, that center area. We're going to run a wire from pin number 2 into the same column. Anywhere in that column will work. I could have attached it right there. It's just fine. But anywhere in that column that our right leg is attached to. The left leg is going to have a ground connection through this row right here, because this row will be connected to ground. All right, let's take a look at our LED. So I put the LED up here. And the anode, the long pin or the long lead of the LED is to the left. Then in that same row, column, in that same column, one end of our 220 ohm resistor will plug into that column and then jump the center divider and plug into the same row. And then I just run a jumper wire from that same row to pin number 12 on our Arduino. And then this leg right here, the cathode, I plug in a jumper wire into the exact same column. Anywhere in that column is fine, as long as it's the same column. And then I run it down to our ground rail right here. Once again, it's got a ground connection because of this right here. And so that forms a complete circuit. So that's it. I put these resistors over here just to remind you what colors you'll need. If you've got a 5-band resistor like I have, Your colors are going to be red, red, black, black. And then that fifth one is your tolerance. I think I've got brown, which I think is 1%. If you've got a 4-band resistor, your colors are going to be red, red, brown. Okay, let's head over to the workbench. Let's build this circuit, and then we'll come back and we'll write some code. Okay, let's take a look at the parts we're going to need to build the circuit, and then go ahead and build it. So of course you're going to need your breadboard. You're going to need your Arduino Uno. I would orient it so that the USB port was pointing to the left. You're going to need one LED. Color does not matter. I'm going to use a blue one. You're going to need a current limiting resistor. I recommend a 220 ohm resistor. If you're using a 5-band color code like I am, it's going to be red, red, black, black. If you're using a 4-band color code, it's going to be red, red, brown for the color stripes. And then, of course, you're going to need a button, and you're going to need a variety of jumper wires. So let's build the button circuit first. And you're going to want to take your button. Something to notice about the button. Notice how, see if I can get this to focus in. Notice how these legs kind of crimp in and point at each other. You want to orient your button when you plug it into the breadboard so that these basically face each other. And I'm going to place it right here. Oops, place it right here so that it straddles this mid port or mid part right here. And in fact, you can't actually even put it in the other direction. So if I spun this and try to put it in, the legs actually don't reach. So if it's not reaching, don't try to bend them. Just put it in there so that they basically are facing like this, and then press it down in there. Okay. Next, I'm going to run power and ground. So what I'm going to do is I'm going to take a black wire. Color doesn't matter, but black usually indicates ground. And I'm going to plug in one end into the ground pin. And the other end is going to go into the bottom row of our breadboard. Bottom row of our breadboard. Then I'm going to get a red wire, and I'm going to connect it to the 5-volt pin. It's over here on the other side. And that was shown on our drawing, so it shouldn't be a surprise. And I'm going to plug it into the second row. So what's going to happen is it's the one closest to that red line. So we're going to have a 5-volt signal all along that second row, going all the way across. And we're going to have a ground signal all the way across this blue line right here. Okay, now let's hook up the button. So what we're going to do is one leg of the button, I'm going to use the right leg of the button. I'm going to plug into my breadboard in the exact same row, exact same column that the right leg of that button is in. Just like that. Then I'm going to plug it into pin number 2 on the Arduino, the one labeled 2. And that's important that we get pin number 2. In reality, a lot of what we're going to be doing will work on just about any of the digital pins, but we specifically want number 2 for a reason that I'll talk about a little bit later. Let me see if I can zoom in. Okay, so we've got the black and the red plugged in here, the red one in the second row. So it gives us a 5-volt signal all along this row, and the black one right here, so it gives us a ground signal all along the bottom row. And I've got black plugged into the ground, and I have the red plugged into 5 volts. Over here, I've got this yellow wire. Once again, color doesn't matter. But I've got it plugged into pin number 2. And it's being run right over here, and it's plugged into exactly the same column as the right leg of our button. And then for the button, the left leg of the button is simply going to go, I'm going to take a wire, plug it into the same column as the left leg of the button. So it's in that exact same column. Anywhere in that column will do. Doesn't matter. And then I'm going to plug it into the ground rail of my breadboard. So it's going to give it a ground signal. So when we press the button, we'll have a complete circuit going all the way around, all the way back to ground, from our pin all the way back to ground. Okay, now let's build the LED portion. Okay, I'm going to take my LED. I'm going to orient it so that the long leg is to my left, and I'm going to place it on the other side of that divider in my breadboard. Okay, so I've got it placed on the other side. I've got it placed so that the long leg is to the left. Okay, I'm going to hook up the short leg first because it's the easiest. It's going to go anywhere in that row. Excuse me, column. That's the same leg as the short leg. That's the right leg. And it's going to go to the ground rail. Next, I'm going to hook up my 220 ohm current limiting resistor. Let me make sure I got the right resistor here. For a 5-band color code, it should be red, red, black, black, and that's what I've got right here. And I'm going to hook it so that one end of the resistor is in that exact same column as the long leg, the anode of my LED. And then it's going to jump the center divider, and I'm going to plug it into the other end of that exact same column. Okay. And then finally, I need to go from that exact same column again. Okay, that exact same column that the resistor is in, over to pin number, let's do number 12. Okay, let's zoom in, see if we can get a better look at everything we just did on the LED. Okay. See if we'll come to focus, maybe. Maybe. Zoom out a little bit. Okay, that works. Okay. So we have our LED plugged in. This left leg right here, the left leg is the longer leg. The right leg is the shorter leg. That's our cathode. The cathode is connected to ground. We have a wire plugged into exactly the same column that the left leg is plugged into. Or excuse me, the right leg is plugged into. And that runs all the way over here to our ground rail. And then we go from pin number 13, which is where this orange is plugged into. See if I can show you there. Pin number 13 plugs into this column right here. Then the resistor, one end of the resistor, is plugged into that exact same column, jumps the center divider, and plugs into exactly the same row that our long leg, or the anode, the LED, is in. So basically what will happen is when we turn that pin on, pin number 12, when we turn it on high, it's going to allow, it gives a 5-volt difference, 5-volt potential difference. That's going to allow current to flow through the, from the pin, through the current limiting resistor, into the anode, up through the LED, where it will then turn our LED on, back down the cathode, and then back to ground. Remember, we've got a ground signal right here, so it'll travel down to here to this black wire, and then back to ground. Okay, let's head over to the computer. Let's write some code to make all this work. Okay, now we're going to write some code in order to read our button and turn on our LED. I've already started a new Arduino sketch and I've already written some code. We'll go through that code, and you're going to notice though we're going to start out by not actually doing anything with the LED at first, and it's to basically teach you something really important about reading buttons and other digital input. So what I did at the very top of the sketch, I created an integer variable. I called it button pin. I set it equal to 2 because that's the button that we're going to read for our pin. That's the button you should have plugged your pin into, button number or pin number 2. Then I created a variable called LED pin, and it's going to hold the pin number that we attached our LED to, which should have been 12. And then finally, I've created a variable, it's an integer variable called button state. And it's going to hold the state of the button. We're going to read the button, and we're going to put the state or the value of the current button in this variable. And by the way, I put all of these up here outside of our setup and our loop function, and this makes them global variables. I can get to them anywhere in my code that I might need them. Now the setup function, I did 3 things. Number 1, I set the pin mode of our button pin to be an input, because that's what it is. It's an input. It allows the user to input information, essentially. We can read whether the user is pressing the button or not pressing the button. And then I'm going to set the pin mode of the LED pin to output, because once again, we're going to be outputting or putting a voltage on that pin to light up our LED. And then I do serial.begin 9600, because at first all we're going to do is take a look at the value of the button pin, because it's going to be a little surprising at first. All right, our main code, we are going to digital read our button pin. What digital read does is it takes a pin number. In this case, it's going to be pin number 2, because that's what button pin is equal to, pin number 2. And it reads a digital value. It's either going to read a high or a low, a 0 or a 1. Okay, digital value means it has a maximum of 2 values. It's either going to be 0 or it can be 1. It couldn't be 255 or 1048 or 2.7. It can either be 0, low, or it can be 1, meaning high. And that's going to put that value into button state. And then what this does, serial.print button state. Serial.print takes basically what we want to print. We want to print the button state. What did we just get? And this \n right here prints a new line. It's a carriage return, so the next thing gets printed on the next line. Then we're going to delay for 1/4 of a second, 250 milliseconds, so that it doesn't scroll by too fast. Now, here's a question for you. Without the button being pressed, what do you think the value of it should be? Should it be 0 or should it be 1? Let's look at our drawing of our circuit again. I think this was it. Okay. So with no button pressed, okay, there is no connection, none, okay, between this pin and this pin. So there is no connection to ground, okay. So right now, the only signal that button number 2 gets is right here. So should it be a 0 or a 1 when we are not pressing it? Now when we press it, what do you think the value would be? Would it be a 0 or a 1? So when we press the button, there's now a connection between ground going through here to here. So you might think that when we press the button, we should get a 0 signal, because now there's a path to ground. And when we don't press the button, well, I don't know. It's kind of hard to figure out. Let's run this code. Where's my Arduino at? There it is. Okay, let's run this and find out. So what I'm going to do is I'm going to hit run. It's going to upload the sketch. Now what I got to do is I'm going to come over here to Tools and Serial Monitor. Okay. So there we go. We're getting a bunch of zeros. I'm not pressing the button. Oh, wait a minute. I'm not pressing the button. Now it just went to a bunch of 1s. And that's weird. Huh. Well, okay. And now I'm not going to press the button. I'm just going to jiggle. Oh, I didn't press the button, I swear. And it went to 0. So let me get my hand close to there. I'm going to jiggle the wires. I'm not even going to press the button. I'm just going to jiggle. Oh, it went to 1 again. And I didn't even get to jiggle the wires. It's doing it on its own. It's like it's just floating between 0 and 1. Let me turn my phone off here. All right. It's just floating between 0 and 1. And then, oh, okay, that time it did jiggle some wires. And now it's back to 0. Let me actually press the button. Oh, pressing the button doesn't actually seem to do anything. It's kind of weird. That's strange. But jiggling the wires definitely has an effect. So let me stop this and explain what's going on. Let's look at our drawing. What's going on is that when we put a pin into an input state like we did, it's in what's called a high impedance state. And it's actually floating, okay? It's actually floating between high and low. And that's because it doesn't have any, if you take a look, this pin isn't actually attached to ground, and it isn't attached to 5 volts or a voltage signal. In other words, it's not really attached to anything. It's just floating out there in midair, kind of. Because when we do not have the button pressed, there is no connection to this ground wire. And so what we have to do is we have to give pin number 2 here an actual connection to either ground or to 5 volts. And we do that through a resistor. It's called a pull-up if we're attaching it. So what we could do is we could attach a resistor from here, okay, over to 5 volts. And what that would mean is we would have a connection to 5 volts. It would be a pull-up resistor, or we could attach it to ground. That would be a pull-down resistor. Now, if we have a pull-up resistor, and we're going to take a look at an actual circuit drawing in just a minute. Without the button being pressed, the value would be 1. Then when we press it, we got a path to ground, and it would go to 0. A pull-down resistor pulls the natural value down. And so with the button not pressed, okay, with the button not pressed, we would have a 0, and when we pressed it, it would be a 1. Now, here's the thing. The Arduino actually has built-in pull-up and pull-down resistors. And we can activate that. Actually, it's got built-in pull-up resistors. Okay, it's got a built-in pull-up resistor. And so what we do is we say in our pin mode, the pin number, which in this case it can be pin number 2. We set it to input. We have an underscore here, and we use the word pull up. What that basically says is, hey, let's set this pin to an input and activate the pull up resistor. So if we're not pressing the button, it should be a 1. And when we press the button, it should go to a 0. So let's run it. Let's compile it. Let's find out. See if this works. Okay, let's come over here to Tools and run our serial monitor one more time. Oh, looky there. We got 1. So let me jiggle some wires. And it's remaining rock steady. Because now that pin number 2, has a connection to 5 volts through this internal pull-up resistor. Now let me press the button and see what we get. And there we go. I'm pressing the button. You can't see it on camera. I really need to get another camera hooked up overhead to this, but it's a 0. When I let go, it's a 1. Press it, it's a 0. Okay. So now what we can do is we can write a little code to activate our LED. And we can do it a couple of different ways. I'm going to show you one way real quick with if statements. We could say if button state equals, and I'm so used to Python, got to put these in parentheses. If button state equals low, it's hard to type reaching around this microphone. All right, so the button state equals low. That means that the person has pressed it. Remember, With a pull up resistor, it's pulling it up to 5 volts. So our signal, when we're not pressing it, is high. If we've pressed it, it's low. So what we want to do is we want to say if button state equals low. Remember, double equal sign, test for equality. Double equal sign, test for equality. All right, we're going to turn on our LED. We're going to say digital right. Our LED pin. And we're going to set it to high. Else, digital right, and LED pin, and let's set it to low. Okay, let me explain the code. We're going to read our button state again. We're going to get the button state and put it into a variable that we called literally button state. I could have named this anything I wanted to. I could have just called it button, or I could have just called it state, or I could have called it is the button pressed, as long as there were no spaces in it. And then what we say is if button state equals low, okay, if the value is low, we're going to do everything that's in between the curly braces. I'm going to do something a little bit different with these curly braces. I actually like this style better, but I know it's not the default style for Arduino sketches. Basically what it says is if button state, and notice the test has to be in parentheses, okay? And notice for the test, for the if statement, there is no semicolon back here. If the value that's in button state, if it's equal, and the double equal sign means test for equality. If it's equal to low, we're going to turn our pin on. We're going to digital write to our LED pin a high value, meaning that we're going to turn that pin on. That's going to light up our LED. Else, I always wished that they chose the word otherwise instead of else. If this, otherwise do this. That's pretty much what it means. If this is not true, else do this. We're going to write a low value. And that's going to turn it off. So essentially, if the button is pressed, we're going to write high. Otherwise, we're going to write low. So let's run it. Let's see what happens. Okay, I know you can't see this, but right now let me just see if I can pick it up. Let's see. See if you can see that. I'm going to press the button. Oh, there we go. There we go. And so it's working perfectly. Working perfectly. Let's look at another way we can do this. So we don't actually have to do all this stuff with if statements. Watch this. All I really need to do is say, get the button state, and then write it out to the pin. I can say digital write, LED pin, comma, button state. Okay. Now let me run it. And what's going to happen here is the opposite. Remember, when our pin is not pressed, when our button is not pressed, pin number 2 reads a high value because it's a pull up. It's going through a pull up resistor that's pulling that value up to 5 volts. When I press the button, it goes down to ground or 0. So when I press it, it's now going to get the value of 0 or low. It's actually the opposite of what we were doing with the if statement. Just like that. So let's look at the code. We're going to read our button pin and put that value into the variable called button state. Then we're going to write that value right out to the LED pin. So if the button is not pressed, button state will be equal to high and our LED will be on. when we press the button, it's going to be equal to low, and it's going to turn our LED off. Finally, show you one more way we could do this. We don't need to put into a variable unless we want to. In this case, we don't really need to. So what I'm going to do, I'm going to Control X to cut that and get rid of that. I could actually put that digital read right here. So what we're going to do is we're going to digital write to our LED pin, and we're going to call the function digital read, which will go out, read our button pin, and put that value right here into our digital write function. So once again, I'm going to run it, and I'm not going to hold it up and show you because it's exactly the same output as the last time. All right, works perfectly. Okay, what we're going to do now, I've showed you how an internal pull-up resistor works. What we're going to do is we're going to build a circuit that has an external pull-down resistor. So I'm going to show you the drawing for that, and then we'll head over and we'll actually build it. It's a incredibly simple change. Incredibly simple change. So let's take a look at that real quick. Okay, I've brought up the drawing of our circuit, and what we're going to do is we're going to add what's called a pull-up resistor to this particular, excuse me, I'm sorry. We're going to add a pull-down resistor. Pull-down resistor. Now, if you remember, the reason why our sketch didn't work properly the first time we did it is because this input right here, input number 2, pin number 2, is floating. It does not have a connection to either ground or to 5 volts. So it's floating. And you'll notice when we ran our first sketch, it would float and randomly move between values of 0 and 1. Then we went in and we told, in code, we said, hey, activate a pull-up resistor. A pull-up resistor. And that pulled up, okay, this pin to 5 volts. So if nothing was pressing the button, it got a high signal when we did our digital input, or digital read, excuse me. Then when we pressed down, it allowed a connection through here to ground, and our value went to 0. What we're going to do is we're going to make a external pull-down resistor. So we really don't need to make too many changes. The first thing we're going to need is we're going to need a 10 kilo ohm or 10K resistor. Now I'm using 5 color band resistors. And so the color for a 10K resistor is going to be brown, black, black, red. Now if you're using a 4-band resistor, your color is going to be brown, black, orange. So here's what we have to do. The first thing we're going to do is we're going to put in our resistor. So I'm going to take a resistor, and I'm going to put one leg of that resistor in line in the same column as this right, okay, as this right leg of our button. Then I'm going to need to make a connection to ground. So in the same column as the other leg of that resistor, I'm going to add a wire that goes to ground. So there we go. Now, this wire here is incorrect. We want it to go to 5 volts. So I'm going to remove that wire. And remember, because of the way we've got this wired, this right here is 5 volts. So I'm just going to put a wire to anywhere in the same column as the left leg. And let me change the color to red. Once again, color doesn't matter, but I'm going to use red to show a 5 volt connection. So now, let's think about what's happening. We've got our circuit powered and everything's going, everything's running. When the button is not pressed, okay, this pin number 2, has a connection through this 10 kilo ohm resistor to ground. So it's going to get a value of 0 if we were to read it, because it's going to be a connection right to ground through that 10 kilo ohm resistor. Now when the button gets pressed, okay, current is going to flow through the path of least resistance, okay? The path of least resistance. So when we press that button, there's now a connection between these two terminals. And it allows current to flow, okay? And we're connected to the 5-volt line right there. And so remember the path of least resistance. So current's going to flow through the button. And it's not going to go down this resistor, because it's going to go down the path of least resistance. And so this pin number 2, is going to read a high signal now, because it's got a path directly through to 5-volt or 5-volt signal. So it's going to read a high value. Then when we let go of the button, we're going to have a path to ground through the resistor, but no path to here. So essentially what this resistor does, it's called a pull-down resistor, because it pulls down this line to ground, to 0 volts. So internal to the Arduino, we activated a pull-up resistor. It does the same thing, only it gives a connection to 5 volts, and it's internal to the Arduino. I actually prefer to do things this way. I actually prefer for there to be a pull-down resistor, because I like having my button that when it's not pressed has a 0 value. Let's go back over to the workbench and let's quickly build the circuit, and then we'll come back over, write some code, and we'll be done.
Okay, so here we are. We've got our old circuit. I'm going to convert it so that we have a pull down resistor. Okay, pull down resistor. My changes are actually really super simple. If you remember, this left leg, let me see if I can zoom in. Okay, there we go. Let me get this out of the way. That's the right leg. This left leg has to now have a connection to 5 volts instead of ground. So I'm just going to move it there to 5 volts. There we go. Pretty simple. Then all I have to do is I'm going to add my 10 kilo ohm resistor, 10K resistor. One leg is going to go on the same column, the exact same column as the right leg of the button. So I'm going to plug it in to the exact same column as the right leg of the button. See if I can get this up. Having a little bit of difficulty. There we go. Okay, so one leg, this leg right here, is in the exact same column as the right leg of our button. I'm just going to bend it and put it in another column over here. There we go. So now I've put it, it goes from here to here. So then I just have to take this and connect it to ground. And so I'm just going to use a blue wire for that. So I'm going to put it in the same column as this leg of the resistor. There we go. And then I'm going to connect it to ground. Okay, so once again, if we don't have the button pressed, let me zoom out just a little bit. Oops, out, not in. Okay, so if we don't have the button pressed, what happens is this pin number 2, has a connection through this wire, through this resistor, and over here to ground. So it's going to read 0 volts or 0. a low signal. When we do press the button, we now have a connection from here, pin number 2, through here, through the button, and then over here to 5 volts. Remember, it's no longer going to see this connection here to ground because it's going to follow the path of least resistance. So when we make that connection with our button, it's like we join these 2 wires right here, the yellow and the blue, and it'll allow current to flow from 5 volts and then through to pin number 2. Okay, let's go and let's write some code. It's going to look almost exactly like the other code. So let's go write some code.
Okay, now that we've added an external pull-down resistor to our Arduino circuit, we're now going to write some code to use it. And in reality, that code is going to be very, very much like the code that we wrote for the pull-up resistor. The only difference is that now we no longer need to tell in pin mode here that it's an input with pull-up resistors, the internal pull-up resistors activated. We now just have to say it's an input. Although we do have a pull-down resistor on it, we don't have to put anything here simply because it's an external pull-down resistor. We're not activating anything internal to the Arduino. Everything else is going to be about the same. What I'm going to do is, for now, I am going to comment this part out, and I'm going to print, kind of like what we did last time. I'm just going to print the value. Let's see, serial.print. I'm just going to print the value of that pin. And then I need to put a little delay in there. Oh, wait a minute. What is this? Random. Okay. Okay. So what we're going to do is we're going to print to the serial console the value of our pin. We're going to say read the pin. Okay, read the pin and print it. And we're going to delay for 1/4 of a second so it doesn't go too fast. So let's go ahead. We've compiled it. It's running. Let's just go to Tools and Serial Monitor. So there we go. Right now we're getting zeros. We're getting zeros because our pull-down resistor is pulling that pin number 12. I'm sorry, pin number 2 down to ground. Now I'm going to press it, and there we go. We get ones. So it's working, and notice it's a stable. I can jiggle the wires, although you can't see that. I can jiggle the wires, etc. It stays at 0, and I press, I get a 1. Press and get a 1. If you're wondering why it's a stream, I forgot to print a new line. And there we go. Okay. So now let's connect this up to our LED. And in reality, we can just do exactly the same thing. And I'm going to get rid of the serial print now. And I don't need the delay. I'm going to take it out. You can leave it in, doesn't matter. So now let me click upload. And there we go. Let's see if this works. So had my wire underneath this book. Okay. So now, not pressing the button. So our pin number 2 is getting pulled down to ground, a 0 value. Now when I press the button, there we go. Works perfectly. So let's look at that code again real quick, just so you can remember how it worked. I'm assuming you know how all this right here works. So right here, we're going to digital write, and inside of the digital write function, we're going to pass to it our LED pin number, which is 12. And we're also going to digital read our button pin. We could have also done this just like this. I've got that button state variable, so I could have said so in this version of the code, if you remember, we're going to digital read our button pin, pin number 2, and we're going to assign the value that it finds there on pin number 2 into button state. So now button state is a variable that holds either a 0 or a 1, either a high or a low. And then we're going to write that value of button state to LED pin. And I can test it out. I'm not going to hold it up. It works. I could also do this with a series of if statements. I could say if digital read button pin equals high. And once again, I'm a little bit too used to Python right now. And I could just say digital write Okay, so now it's just a series of if statements. We're saying, hey, if, let's read the button pin, and if it equals high, do the stuff that's in between these curly braces, which is just writing high to the LED pin, else, or otherwise, digital write low to the LED pin, turn it off. And let's see if it compiles. It's running. I'm not going to hold it up. I'm just going to give it a try, and it works. Okay. I'm going to show you one last way to do this. It's with what is called an interrupt. And I think the easiest way for me to explain this is to write the code and then explain it. So over here in setup, I'm going to do a function called attach interrupt. Provided I can remember. I think that's it. Okay. And then what I'm going to do is I'm going to get rid of all of this because we don't need it. I'm going to write a function up here. And all right, let me compile it. Yeah, I thought something was wrong there. It doesn't look right. Digital pin to interrupt was not declared in the scope. There's something weird going on. I spelled interrupt wrong. There we go. Okay. Okay, attach interrupt, and once again, I spelled interrupt wrong. Oh my gosh. Okay. Let me compile it. Okay. So now I'm ready to explain what an interrupt is. The Arduino has the capability that on certain pins, okay, and pin 2 happens to be one of those certain pins on the Arduino Uno, it's pin number 2 and pin number 3, to detect a signal change on that pin and interrupt whatever is running, doesn't matter where it is in the code, doesn't matter where, and run a function called an interrupt service request when that pin detects a signal change. And in order to do that, what we do is we use the function attach interrupt. And so we're going to attach an interrupt function to a pin. The very first thing we're going to call inside of that function is this function right here, digital pin to interrupt, and we're going to pass to it the pin that we want, in this case button pin. Then the name of the function that we want to have happen, and then I'll explain this in just a minute. Right now, this is going to happen anytime it detects a signal change, okay, going from high to low, low to high, etc. And so when it detects that, it's going to call this function right here. And if you're not familiar with functions in an Arduino sketch, for right now, if you're not familiar with it, just use the word void right here. Start out your function with the word void. Like I said, if you don't understand what that means, don't worry about it. The name of the function, in this case, I'm going to call it button callback. And then open and close parentheses. Then everything that you want to have happen inside of that function, you're going to put inside of open and close curly braces. In this case, all we're going to do is we're going to write to our LED pin whatever value we read on the button pin. And so that's going to cause it to be exactly the same as before. I'm going to run this. When I press the button, it works. Now then, a couple things about interrupt functions or interrupt service request. You should keep whatever you do inside of that interrupt service request very, very, very short. Don't do a huge amount of stuff, because literally everything else stops running and it immediately interrupts. That's why it's called an interrupt. It interrupts whatever your program was doing and goes and runs your interrupt service routine. Okay, let's take a look at the different options that we have for this very last parameter right here, because it can have a big effect on when your callback function gets run. Right now I have it set to change. So anytime our button state changes, our interrupt routine is going to get called. And I'm going to show you that. What we need to do, I'm going to do a little printing inside of our function. So that means I also need to start up serial.begin 9600. So what's going to happen when our interrupt routine gets run? It is going to come up here. It's going to write inside button callback and then set the state of LED pin to whatever button pin is. So let's run it. And let's go to our serial monitor, tools, serial monitor. Okay, right now I do not have the button pressed. I'm going to press the button, and I'm going to hold it down. So I'm pressing and holding down. Notice that inside callback only prints one time because it changed. Okay, it changed from low to high. Now when I let go of the button, I get another print because it has changed from high to low. So change literally means it gets called whenever there is a change on the button. And so it's going to get called when we press it and when we let go, because that's a change. Now, let's do this low. So the other value we have is that we can use is low. It's only going to get called when the value of the button or that pin is low. So watch this. Tools, serial monitor. Okay, so right now, notice that it's printing a bunch, printing a lot. And that's because, remember, we have a pull-down resistor on our pin. So our pin is basically constantly low. And so it's getting called constantly, over and over and over and over and over again, because our pin is perpetually low until we press it. Now, I'm pressing the button now. And so you will notice that it has stopped. It is no longer printing because our callback function is not getting called anymore. And it's not getting called anymore because as we have this pressed, the value in our button is high, and we have it set to only get called when our pin is low. Now I'm going to let go, and it goes back to it. The other options we have are rising and falling. When I use the word rising, it is only going to get called on what's called the rising edge, when it is going from low to high. So let me come over here to tools, our serial monitor again. So it only gets called when it goes from low to high. So right now our button is low, so it should get called whenever I press the button, because that's going to be going from a low value to a high value. And sure enough, it does, and my LED turns on. Now it won't get called when I let up, because that was not going from a low to a high value. That was going from a high value to a low value, what's called falling. So now I'm going to press it again. It's going to go from low to high, and that's going to turn it off. Actually, it's going to keep it back on. So each time I press the button, it gets called. Now it might get, you might see a few prints, and that's because our button needs to be debounced, but I'm not going to talk about that right now. The final option we have is falling. And if we have it set to falling, it's only going to get called on the falling edge of the change. In other words, when it is going from high to low. So right now our button state is low. When I press the button, let me bring up the serial monitor. Okay. When I press the button, we're going from low to high. Therefore, our interrupt service routine does not get called. However, when I let go, we're going to be on the falling edge. We're going to go from high to low, and it should get called. And it does. Once again, pressing the button does nothing, but letting go of it causes it to get called. Okay. So that's pretty much it for using a button for input on an Arduino. I know the interrupt stuff was a little bit advanced. If you don't understand it, don't worry about it. You can easily use the stuff that came before without using the interrupt. You don't have to use the interrupt if you think it's a little too much for you. You can put everything right here in your loop and just say something like, if digital read button pin equals high, digital write LED pin else. Once again, I always wish it was otherwise. Digital write LED pin low. And there we go. Works perfectly. Don't even have to use an interrupt. So if you don't understand that interrupt stuff, don't worry about it. It's kind of an advanced topic. So there we go. If you got any questions, ask them down below in the comments. I would really appreciate it if you're not subscribed to the channel to please subscribe to the channel. And once again, today was a great day to learn to code, and I will see you next time. Bye-bye.